Good morning. Welcome to the Society for Range Management 2022 annual meeting. Our symposium this morning is about transformational climate change on rangeland. I'm Joel Brown and I'm your moderator for the symposium this morning. Our first speaker this morning is Dr. Ken Spaeth. Ken is with the NRCS Grazing Lands team in Fort Worth. And Ken is going to talk about evaluation of current rangeland conditions. Ken, it's yours.
Okay, thank you, Joel. Good morning, everybody. As the title says, I want to give you an overview of some of the current rangeland conditions and trends based on non-federal rangeland community types. We're using the National Resource Inventory data set 2004 to 2008. And based on the whole US sample, we have over 30,000 points on the ground now. And so in this presentation, I want to briefly look at some trends based on Similarity Index, apparent rangeland trend, interpreting indicators of rangeland health, and then we'll look at a couple of resource concerns that kind of dovetail with basic overall trends and conditions from the NRI, and then we'll talk about the need for specific experimentation to sort out any climate change effects on rangelands. Long-term studies are definitely needed. So the NRI, this is what an NRI plot looks like. It's a 0.4 acre macro plot with 250-foot tapes aligned north and south, east and west, and a variety of data is collected on the transects within the macro plot and for the field. So for example, up in the upper left-hand corner, we record any obvious conservation practices that are applied on the site, resource concerns that the field crew sees, and then there's macro plot measurements. We do the rangeland health assessment of the three attributes on the macro plot. We do rangeland trends, census, full census of ID and plants, and assigning a density value to them, and then we record disturbance indicators. Along the transect, a variety of data from plant productivity, canopy cover, soil stability tests, etc., plant heights, pretty in-depth protocols in the field. So we're going to be looking at some ecoregions based on level 3, just to kind of look at some basic trends across the central Great Plains, northern Great Plains, and then we'll move further west into the Colorado Plateau and the Great Basin, just to kind of show you the power of the NRI. We're not going to specifically get into the detail, but I thought I would select some major ecoregion and just basically show you what the NRI is telling us. So for example, with the Similarity Index, these are, there's 4 ecoregions here, basically in the central Great Plains. The upper left, this is the average Similarity Index for the whole US based on 29,600 points is almost 30%. And then we'll look at, you can see the comparison of these various ecoregions. Note that the Flint Hills and the Nebraska Sand Hills are above 40%. Based on my knowledge and working in these areas, they're largely comprised of native tall grass species like big blue stem Indian grass, side oats, grama, switchgrass, things like that. They seem to be a lot more resilient than perhaps other species, major grass and forage species that are occupied more of the northern central Great Plains. And So then we move over to the right and we go up further north into 4 ecoregions up closer to North South Dakota in that area. And just showing you the basic type of data that we can glean from the NRI. And I think it's important to note that, in evaluating any kind of trends or assigning what the effects of climate change or any other kind of disturbances, we need to establish some kind of a baseline of some basic conditions. And that's what I'm doing here is presenting a starting point. Now, the 2 bottom graphs actually represent repeat visits of the samples. For example, if the bars are red, that signifies a significant difference. Now, Similarity Index is based on, basically it's a comparison of the existing plant community production of current year's growth compared to the reference community in an ecological site description. So it's just a mathematical computation of basically the historic plants in the ecological sites. So for the US, there is a slight drop, the high plains a slight drop, and then the green bars in the other 3 ecoregions, there is no significant change. And then we move up further north toward North South Dakota, eastern Montana, Nebraska, and there's some of the results there. If we move further west into the Wyoming Basin, for example, in the Colorado Plateau, there's kind of a basic average for the whole ecoregion, and then we'll look, and then the right graph actually shows the comparison of a first sample and a second sample, and these samples on the average are 6 years apart from the first visit to the second visit. So for the Colorado Plateau, it's right on the borderline. It just crossed the significance level of 0.05, so it's real borderline. But the Central Basin and Range, there was a significant drop there, even though the percentage maybe only dropped maybe 3 or 4%. It was a significant change. So next we'll look at apparent trend. That's kind of a subjective determination based on whether the plant community is moving away from the historic plant community, or it's not apparent, or it's moving toward. It's just a simple procedure that NRCS uses, and we talk with ranchers about what their trends are. It's typically not followed up with any quantitative measurements in the field, although you can do quantitative measurements based on canopy cover or production and get some kind of a feel for what the apparent trend is. So, just looking at the trend across the US, note that all the values are below 2, between 1 and 2, which is away and not apparent. So actually the trends are not moving toward HPC in any of those ecoregions. And even in the Flint Hills, we had a drop. In the High Plains, we had a drop of apparent trend. And then to the right, we move up a little further north, and you see the same types of data. And then further west into the Wyoming Basin, Northern Basin, this is just an example of what we're seeing in terms of apparent trend on some of these large ecoregions. So now we'll look at Rangeland Health, and this is just an example of the Central Great Plains. So we subdivided the data into the categories. One, for example, if you're familiar with Rangeland Health, there's 5 categories. The first one is none to slight departure from reference, to the most extreme to total departure from reference. That's number 5. So that just shows you a histogram of what the data is showing in the Central Great Plains with respect to, say, biotic integrity. So 53% of the acres fell into category 2, which is slight to moderate departure. 11.6% was in the moderate departure range. And then to the right is the soil surface stability attribute, and then below is the hydrologic function. Typically, we see the data for soil surface stability and hydrologic function are always very similar, since they use a lot of the same indicators to determine that attribute. And then there's the map of 27 expands through Oklahoma, Texas, and Kansas, and Nebraska. So it's a quite large ecoregion. Okay, so we look at we're just going to look at biotic integrity across some of these central Great Plains, and you can see that we're somewhere between none to slight, slight to moderate for these 4 ecoregions. And we move up into the north, and we see the same trends there. So now we look below, and we see whether there was what the difference is between a 6-year period. And in the U.S., the bar is rising, which means that we went from, say, a 1.7 to now 1.9, for example. So we're starting to move more into the middle of slight to moderate departure. And so for the high plains and the central Great Plains, the situation was moving toward more toward a moderate or slight to moderate departure from the first visit. The Flint Hills, actually, the situation got a little better. In the Nebraska Sandhills, again, the trend is starting to move more toward slight to moderate. And then you see the same situation there, the same types of data for more than northern Great Plains. And now we'll quickly look at what is going on with most of the West. It's nice to know, for example, in the Wyoming Basin, Colorado Plateau, and Central Basin and Range, there is no significant change between the 6-year period. So this is just showing you the types of things we can look at with the NRI data, but it also establishes, a baseline of what are the current trends. So if we wanted to start monitoring these sites and collecting more information, or designing experiments to look at the effects of management coupled with climate change, coupled with invasive species, and perhaps lack of prescribed burning or things like that. So, when we look at, I guess the question is, with climate change, what could we learn from, say, focused long-term experimental studies? Obviously, we could look at maybe the uncertainty of projected climates. We could look at what was the effect of number 6, for example, greater atmospheric CO2, the results of reduction in perennial plant growth, what's the establishment of non-native invasive species, what is the effect of maybe more altered or more frequent fire regimes. So when you think about climate change and rising CO2, I thought it would just be interesting to quickly look at the evolution of grasslands over the geologic history. So 70 million years ago, members of POA-AC started to appear in Northern Africa 70 million years ago. And then by 66 million years ago, there were open habit grasslands of both C3 and C4 grasses. And then 56 million years ago, for example, POA-AC was nearly worldwide in distribution, and then there was well-established 55 million years ago in North America, so forth and so on. I think it's almost impossible to conceive 55 million year history. So if we look at what the development of some different, for example, in central North America, this square here is the first open habit grasslands became well established around 25 million years ago. But if you look at some of the atmospheric CO2 contents, they were 1,500 to 2,000 parts per million at various periods of the development there by this green dot. So I mean, my point is, when we start thinking about climate change, we got to realize that these grasslands and these grass species have seen everything that nature or the environment can throw at it. I mean, and at best, you know, as rangeland managers, we're looking at a window of during our career of maybe 30 to 40 years. So what are the major challenges to U.S. rangelands? Okay, so quickly looking at the resource needs based on the NRI. The number one resource concern based on all the rangelands in the U.S. was noxious and invasive plants, which accounted for almost 60% of the total acres recorded in the NRI. Said, yes, noxious and invasive plants is an issue. And so then we also look at health and vigor. Almost maybe 45% of the acres sample had a concern about that. We look at the third ranking one, forage quality and palatability, 40% of the acres. So that's showing us what are some of the key resource concerns on our rangeland. So if we look a little deeper, in terms of invasive species, it's not surprising to see that Bromus tectorum, or cheatgrass brome, occurs on over 25% of the acres on non-federal rangeland. And so we'll also look at Kentucky bluegrass, you know, 20 to 22%. We look at smooth brome, and then we look at field brome. Those species are quite prevalent and dominant on a lot of our rangelands. So for example, quick look at a histogram of 3 ecoregions occupying the Northwest glaciated plains, the Great Plains, and the average canopy cover percent of Kentucky bluegrass for these 3 ecoregions was 22%. Okay, let's look at cheatgrass brome. This is for the entire US. The average foliar cover percentage of cheatgrass where it occurs is 16%. And it occurred on 55% of our NRI points. So last but not least, we'll quickly look at what the situation was in terms of trees and shrubs. Okay, Opuntia species are a problem, or at least they occur on about 22, 23%. Mesquite was the third most prevalent shrub, invasive shrub, even though it's a native species. Of course, last but not least, Joel Brown, there's Laria tridentata. And then we look at some of the juniper species, Monosperma, Virginiata, and Ashii, which is a Texas species. So hopefully here, we presented at least the power of the NRI and establishing some benchmarks and starting points to evaluate future conditions and future resource concerns. And only experimentation can sort out the underlying factors of plant community change. The NRI is not an experiment, it's an assessment process. And it basically provides some data, but it doesn't really show like what are the causes of certain situations. We have to maybe develop hypotheses based on looking at the resource needs, like noxious and invasive plants are having a tremendous impact on our rangelands. Lack of wildfire, grazing, what effect does overall grazing have? We do record whether grazing is light, medium, or heavy. And so we could We can develop a picture and a storyline, but experimentally, I wouldn't go any further than that. That's where science and experiments come into play. So that basically completes my presentation.